Hi guys, in this video we are going to learn about graphing absolute value functions. Okay, so we're going to look at the parent function here of y equals the absolute value of x. And when you graph an absolute value function, it is always going to look like on a graph, just so that you know, it's going to look like a V. It's always going to look something like that. Now, it's not a U like a parabola, it's a V, okay? Now, the vertex form of any absolute value function, and this might look a little bit familiar to you because of your quadratic function formula in vertex form. So it is y equals a times x minus h plus k. Okay, this is the vertex form of a absolute value function. What this tells you is a lot of things. So the vertex will be at hk. Now I want you to notice that there's a minus sign there. So if in our problem we had x minus 3, that means h would be 3. It wouldn't be negative 3. Okay? If this were x plus 3, then this h would be a negative 3. So we have to pay attention to that. The axis of symmetry is always at x equals h, whatever h is. So that is your h value. And then the domain of all absolute value functions is the same as the domain of all quadratic functions. It's negative infinity to positive infinity. It will always be that. And the range is always going to be dependent upon your k, okay? So there's two things that it actually depends on, the k and the a. So if your a, I'm going to write this over here. If a is positive, then your V opens up like that, okay? If A is negative, your V is going to open down like that, okay? So if A is positive, it opens up, and if A is negative, it opens down. Now, if your graph opens up, okay, if it opens up, then your range is always going to be y is greater than or equal to k. If your graph opens down like this, the range is going to be y is less than or equal to k. All right? So we're going to refer back to this as we do these problems down here. Now remember, the parent function is y equals the absolute value of x. So I'm going to write here absolute value of x is my parent function. And that is actually the first one that I have graphed here for you, okay? So in other words, if I put in 1 for x here, if I put in 1, I get 1, and if I put in negative 1, I get 1. If I put in 2, I get 2. If I put in negative 2, I get 2. So I drew my parent function in. So if you want to pause the video at this point and draw in your parent function, you can do that. Now I'm going to work these 3 over here that are in here, these 3. And then you're going to do the 2 that are on the bottom. So let's try these 3 up here. So we've got f of x, and it says to do it in blue, and I actually do have a blue, so I'll go ahead and do that, okay? So what is my a here? Now remember, up here, a is the number that is in front of the absolute value. So there is nothing in front of the absolute value, so when there's nothing in front of a variable, we always say it's a 1. So we have 1 there. H, there is nothing, remember that h is inside the absolute value bar. So if there's nothing there, that means h is 0. And then my k is the part on the end. So my k here is negative 2. Okay, now remember, your vertex is at hk, and I've already labeled what h and k are. So my vertex is at 0, negative 2. The axis of symmetry is x equals h, and h is the first one in my vertex here. So this is x equals 0. The domain is always negative infinity to positive infinity. And the range, okay, so we've got to look at A. A is positive, which means it opens up. A is positive, it opens up. If it opens up, then that means we use y is greater than or equal to k. So y is greater than or equal to k, which is negative 2. All right, now if I come over here and I plot some of these points. So 0, negative 2. Now, if you wanted to, you could do an X and Y here chart. So we've got 0, negative 2. If I put in 1, I would get 1 minus 2, which is negative 1. So at 1, I'm going to get negative 1. If I put in negative 1, I'm also going to get negative 1 because the absolute value of negative 1 is 1, and then minus 2, that's going to give me negative 1. So I've got another negative 1 right here. Okay, now you'll notice what it's doing to this graph is it's moving this graph down 2 on each of these. So I'm going to go ahead and draw these points in here. So you got a graph that looks like this on the right side, and then I'm going to key in these over here. And then we've got a graph that looks something like this. Okay, there's that side. And then we've got this side. So basically what we did to this parent function, absolute value of x, was we moved every single point down 2 units. Okay? Then our next one says to use green to do the next one. I don't have a green, so I'm going to use orange. Okay, so I'm going to use orange here. All right. So we're going to label what all of our things are here first. Remember, here's your vertex form to look back at if you've forgotten. So the A is the number in front of the absolute value. So A is negative 1, since there's a negative there. H is the number that's inside, but remember it's x minus h. So since this is plus, that's going to make this negative 3. And then K, there's not anything out here on the end, so my K is going to be 0. Okay? Now my vertex is at HK, so that's negative 3, 0. My axis of symmetry is at x equals whatever this h right here is, negative 3. The domain is always negative infinity to positive infinity. Now my range. Okay, A is negative. Let's go back up here. If A is negative, it opens down. When it opens down, that means y is less than or equal to k is my range. So y is less than or equal to k, which is 0, is my range. Okay, so I'm going to come over here and I'm going to plot some points here. The first point I'm going to plot is negative 3, 0. So negative 3, 0. That's going to be this point right here. Okay, now you can make a T-chart and do some points. We got negative 3, 0. Okay, what if I put in 1? 1 plus 3 would be 4, and then the negative outside would give me negative 4. So at 1, I'm going to get negative 4. Okay, if I put in 0, I'll put in 0. 0 plus 3 is 3, and then you can't do negative 0. 0 plus 3 is 3, and then negative 3, because of that out there. So at 0, we've got negative 3. Okay, what if I put in negative 1? Negative 1 plus 3 is 2, and then the negative would make that negative 2. So can y'all see what this is doing? It's going up by 1s. So that means it's going to go down this way by 1s. Okay? And it's going to do the same thing. Remember, this makes a V, so it's going to do the same thing over here on this side. If I were to put in negative 4, negative 4 plus 3 would be negative 1, and then the negative on that side would make that a positive 1. No, wait a minute. Let me think about that again. Negative 4, if I put in negative 4, that would be negative 1, and then the absolute value of negative 1 is 1. The absolute value of negative 1 would be 1, so that would make it negative 1. Sorry, guys. Confused myself there on that one. So if you get confused, write it down. And the reason I knew I was wrong in what I was saying is I knew my graph had to go down this way. Okay? So now we've got a graph that looks like this. And this. All right? So that is our orange graph. All right? Now it says to use red and do number 3. So let's try number 3. All right, A is a positive 4. That's the number in front of your absolute value bar. H is this number right here. And remember, it's X minus H. So since this is a minus, that's going to be a positive 1. And then my K is 2. Okay, my vertex is at HK. So that's at 1, 2. The axis of symmetry is going to be at X equals 1. The domain is negative infinity to infinity. And the range is, we got to look at A first. A is positive. So if A is positive, it opens up. And when it opens up, that's Y is greater than or equal to K. So Y is greater than or equal to 2. All right, so I'm going to do a little T-chart here and come up with some points because this 4 out here is kind of going to make this look a little bit different, okay? And I'll show you what I mean by that. So we've got the point 1, 2. That's this point right here. Okay, so we got the point 1, 2. What if I put in a 0? 0 minus 1 would give me negative 1, but the absolute value of negative 1 would be 1. And then 1 times 4 would be 4, plus 2 would be 6. So at 0, I'm going to get 6, which is way up here. All right, what if I put in 2? Okay, 2 minus 1 is 1. The absolute value of 1 is 1. 1 times 4 is 4, and 4 plus 2 is 6. So at 2, I also get 6. All right, what if we put in 3? 3 minus 1 is 2. The absolute value of 2 is 2. 4 times 2 is 8. And then 8 plus 2 is 10. So at 3, I get 10 up here. If I put in negative 1, negative 1 minus 1 would be negative 2. The absolute value of negative 2 is positive 2. 2 times 4 is 8. Plus 2 would also be 10. So notice this time that your graph is a lot closer together than what we had on those other ones. So we have a graph this time. It's not as flattened out. Do you notice that? It's not as flat as what these were. So this is what we call a vertical stretch. We call that a vertical stretch. We stretch that graph up, okay? It's almost like pulling a rubber band. So you can think of a stretch. So if you have a rubber band, you think of a stretch. When you pull it out, it makes it longer, okay? So that's what we're doing. We're stretching it out. When your A value is greater than 1, that's what's going to happen. If you have an A value that looks like a fraction that's between 0 and 1, it's actually going to be called a vertical compression. It's going to push that thing out farther. Okay, so in this case, we had a vertical stretch. All right, if you have any questions, let me know.